All right. Hopefully everybody has their warm-up pages out now. Let's go ahead and start working our way through these. I think you guys will see here in just a couple problems why I wanted to do this together instead of just leaving you on your own to do it today. For numbers 1 and 2, we want to write the equation of a line that is parallel to the given line and contains the point. What do I need to have in order for that line to be parallel? Same slope. If you look at number 1, can we look at the equation and know what the slope is just by looking at that equation? Yes, it's in slope-intercept form. So what is the slope on number 1? 3. So here's our slope. And it needs to go through this point right here. So this is going to be my x1 and my y1. We need to use point slope form. Y minus y1 equals m times x minus x1. So I have y minus, what do we put in for y1? 2. Equals, what goes in for m? 3. And then parentheses, x minus what? X minus 1. From here, I need to distribute the slope to everything inside the parentheses. Give myself the room I need for that. So I'd have y minus 2 equals what? Three x minus 3. And then to get this into slope-intercept form, what do I still need to do now? Add 2 to both sides. So my final answer here in slope-intercept form would be y equals what? 3x minus 1. All right, so number 1, pretty straightforward. Similar to problems that we did the other day. Number 2, can we look at that and just grab the slope like we did on number 1? It is not in slope-intercept form, so we can't do that. I need to put it in slope-intercept form first, and then I can use my point slope form. So slope-intercept form has which piece all by itself? Y needs to be all by itself. So I need to get rid of anything over on the left that's not y. So what needs to go first? We're going to subtract that x from both sides. So I would have 2y equals, slope-intercept form is mx plus b. So I need the x part to come first, negative x. Is the 6 positive or negative? Positive, so this would be plus 6 back here. Is that slope-intercept form? Almost, though. What do you not get? It's not in slope-intercept form yet because the y is not totally and completely alone. There's still something over there with the y. What's still with the y? 2. I got to get rid of it. What's connecting the 2 and the y right now? Multiplication. So how am I going to make it cancel? How do I get rid of it? Divide. I'm going to divide by 2. And that means I have to divide every piece on the other side by 2. So I have to divide the negative x by 2. And I have to divide the 6 by 2. Every single part has to get divided. All right, so that would give me y equals, so now it's going to be slope-intercept form. I have negative x divided by 2. That's negative how many x's? It's a negative what? when you just have that negative sign, is it -7, -5, -1? So that's a -1x over 2, which is -1/2 x. My -1 is in my numerator, the 2 is in my denominator, the x just comes out to the side. And then plus, and then I have to do 6 divided by 2. 6 divided by 2 is what? 3. Now it's in slope-intercept form. Now can I identify the slope? What is the slope? -1 over 2. Here's m. So now I can do point slope form. Y minus y1 equals m, parentheses, x minus x1. And I need to substitute in those pieces that I have. So y minus, what are we putting in for y1? 3 came from this ordered pair right over here. So y minus 3 equals what? -1 over 2 goes in the place of m. And then I've got my parentheses. And that'll be x minus what? X minus 4. Close my parentheses. And then I want to do what next so that I can get it into slope-intercept form? I thought I heard somebody say it. It starts with a D. Distribute. I'm going to take that -1/2 and distribute it to both of these pieces here. So I would have y minus 3 equals -1/2 x. All right, now I have to do -1/2 times -4. Let's just start off with its negative times negative. So my answer is going to be positive. So this is going to be a plus. So I took care of the negative and the negative. I have 1/2 times 4. Well, what's half of 4? 2. So y minus 3 equals -1/2 x plus 2. Let me bring that over here so it's a little easier to see. What do I still need to do to this then to get the y totally alone? We're going to add 3 to both sides. And so slope-intercept form for my answer, y equals -1/2 x plus 5. For numbers 3 and 4, it's similar to what we did up in numbers 1 and 2, except do I want parallel, same slope? Now I want what? I want perpendicular. So how do I make something perpendicular? I know with parallel, I just grab the same slope. This one will be what? Different slope. How? Reciprocal and opposite sign. So perpendicular slope, reciprocal. What does reciprocal mean to do again? Flip our fraction. So reciprocal and opposite sign. All right. Here's the point that it's supposed to go through. So here they're telling me my x1, y1. Can I look at this equation, find the slope so I can make it reciprocal and opposite sign? Not with the way it is right now. What should my first step be then as I'm trying to get it into slope-intercept form? Move the x to the other side. And what operation should I use to do that? Addition. Let's add 3x to both sides. So that would give me 4y equals 3x plus 16. And I have now just run out of space. So let's bring it over here. 4y equals 3x plus 16. Is it in slope-intercept form yet? No. Almost, though. What do I still need to do? Divide by 4. So I divide the left side by 4, and I divide everything on the right side by 4. So 3x gets divided by 4 and 16. So y equals 3 divided by 4. Does that come out to a whole number? Then I'm just going to leave it as the fraction. Can it reduce at all? Anything that goes into 3 also goes into 4? Nope. So it's just going to be y equals 3/4 x plus what? Plus 4. All right, so here's the slope, 3/4. I need it to be perpendicular. So what is the perpendicular slope going to be? -4/3, -4/3. All right, let's use our point slope form now. Y minus y1 equals m, parentheses, x minus x1. All right, so this is going to be y minus what? Y minus 2 equals, what goes right after my equal sign? -4/3 in the place for my slope, because I want the reciprocal and opposite, so it's perpendicular. And then x minus 3. Not done yet, because I have to take it from this form into slope-intercept form. So what do I do now? Distribute. We're going to distribute that -4/3 inside the parentheses. So y minus 2 equals -4/3 x. Now I have to multiply this fraction to this whole number. First thing I notice is it's a negative times a negative, which means I'm going to get a positive. So this needs to be a plus 4/3 times 3. What do you say? 4. Last thing I need to do so that this is in slope-intercept form is I need to add 2 to both sides. So my answer would be y equals what? -4/3x plus 6. All right, we got one more to go and then we're done. Are we in slope-intercept form on number 4? No. What should my first step be as I'm trying to get it into slope-intercept form? Subtract 4x from both sides. Since I need it to be mx plus b, it's going to be -4x, and then that 9 is positive or negative? The 9 is positive, so -4x plus 9. Don't forget to drop that negative sign down with your y. Is that in slope-intercept form? No, I got that negative out in front. I need to get rid of this. How do I get rid of a negative sign like that? I can multiply by what? By -1. We can multiply, or you can divide. Multiply one side, I got to multiply everything on the other side then. So negative times a negative gives me a positive y over here. I have to distribute this -1 to both pieces. What's -1 times -4x? Positive 4x. What is -1 times 9? -9. All right, so now I have the slope of this line, that's 4. So what will my perpendicular slope be? -1/4. All right, time for point slope form. Y minus y1 equals m, parentheses, x minus x1. So this will be y minus what? Negative 6. I'm subtracting a negative there. Be careful. There's my y1 equals, what goes right after my equal sign? Negative 1/4. And then inside the parentheses, I have x minus what? X minus 8. Here's my x1 over here. All right, I need to kind of do two things at the same time. I'm subtracting a negative over here on the left, so that's going to turn into what? That's going to turn into a positive. So this will be y plus 6. And then on the other side, I need to distribute that negative 1/4 to each of the pieces inside my parentheses. So I'll have negative 1/4 x, negative 1/4 times negative 8. Negative times negative will give me what? Positive. So this is going to be a plus something. What is negative 1/4 times negative 8? 2, absolutely. Last thing I need to do, get the y alone. What should I do to get the y alone? Subtract 6. So that would give me y equals negative 1/4 x. And then what happens when I combine 2 and negative 6? I get negative 4 or minus 4. Very, very nicely done. We need to finish up just a little bit in your book, and then we're going to be in the extra notes. Don't put your warm-up away. Today's Friday, so you guys are going to be turning that into me. I need your books on page 227, and then you also need that extra notes packet that we've been working through. Page 227 in your book, and then the extra notes packet. All right, so we've been asked to find the value of x so that lines M and N are parallel. Here's line M, and here's line N. If those lines are supposed to be parallel, what's my transversal? K is my transversal. We're supposed to find the value for x that would make those two lines parallel. And these are the two angles they gave me that have x in them. Are those two angles are on the same side or opposite sides of that transversal? Same side. Are they interior to M and N, exterior to M and N, or do they have matching corners? Matching corners. So what do we call that angle pair if it's matching corners? Corresponding. And if the lines are parallel, corresponding angles should be congruent or supplementary? Congruent. Well, if those angles are congruent, then what does that mean about their measurements? They are equal. They are the same. So since the measurements are equal, that means I take 6x minus 3, and I set it equal to 2x plus 1. And now I need to solve this for x, which means I need to get my x's all on the same side first. How do I group my x's together? Subtract 2x from both sides. All right, so 6x minus 2x would be 4x. 4x minus 3 equals 1. Then what do? Add 3 to both sides. So I have 4x equals 4. Divide both sides by 4, and I get that x equals what? X is 1. Now I want to know what we just used to be able to solve that. So we said back at the beginning that these two angles that we set equal. What was the name for that angle pair? What did we name them? Corresponding angles. And we were using these corresponding angles being the same size to show that those lines had to be parallel. So this is the corresponding angles theorem, converse. It's the converse because we were showing that the lines were parallel. We started off by saying the angles are congruent, and we used that to say the lines must be parallel. That's a converse. When we start by knowing the angles are parallel, and we use that to say that, when we start by knowing the lines are parallel, and we use that to say the angles would then have to be congruent, that is just the theorem, not the converse. When I want to show that they're parallel, that's when we use the converse. All right, let's hop down and do part B, and then we're going to be in those extra notes. So in part B, we are supposed to find angle LMN so that line A is parallel to line B. LMN, that's this guy down here. What variable do you notice in that angle? There's an x. It's 4x plus 6 degrees. So we're going to have to find x, and then we're going to have to plug it in there. If I'm going to show that A is parallel to B, that means one of my angles needs to touch line A, and the other one needs to touch line B. What angle do we have that touches line A? What angle? RST, this angle right up here. They told us that that is 9x minus 12. And do we have an angle that touches line B? Yep, that would be the LMN that I need. I have another angle that touches line A too, but they just gave me more than I need on this one. That's okay. We're supposed to show that these two lines are parallel, finding x so that the lines are parallel, and then we'll take x and plug it back in here. What would I call this angle pair here? Vertical angles have to be formed by just two intersecting lines. Alternate exterior angles. Are alternate exterior angles supplementary or congruent? Congruent. And if they're congruent, what does that mean about their measurements? They're the same, they're equal. So how do I show that? Set them equal. So I'm going to have 9x minus 12 is equal to 4x plus 6. And now we need to solve this for x. It's my first step to solve it for x. Group my x's on one side, so I'm going to subtract 4x from both sides. That would give me 5x minus 12 equals 6. What next? Add 12 to both sides. I'm going to have to bring my work over here a little bit. That would be 5x equals 18. What do I do now to solve this for x? Divide both sides by 5. What is 18 divided by 5? 3.6. So here's x. Was that what they asked me to do in the problem? Find x. No, I'm supposed to find what? LMN, the measurement of angle LMN. What was the expression that we had for that? 4x plus 6. And we just figured out that x is how big? 3.6. So 4 times 3.6 plus 6. What is 4 times 3.6? Grab a calculator if you need to. What is 4 times 3.6? 14.4. So I have 14.4 plus 6, which would be what? 20.4. Since this is the measurement of an angle, it gets a degrees symbol with it, which means my answer is A, B, C, or D? B. Nice work. Yes. Go ahead and pull out those extra notes. We're going to switch gears from solving to proving. In order to do the solving part, you have to know what your angle pair is called so that you know whether you're going to add them and equal them to 180 or whether you're going to set them equal to each other. All right, extra notes packet, bottom of page 5 first. Statements and reasons. You might find that yellow page really helpful as we're going through doing our proofs because this has our reasons on it, so you might want to pull that out as well. Bottom of page 5 is where our first proof is. What should my first statement be here? What was my given information? Angle A, is congruent to angle H. And why am I allowed to say that? What's the reason? Given. All right, so I'm going to mark that on my picture. Angle A is congruent to angle H, this one down here. We're trying to prove that line V and line W are parallel. Look right down here with me. Is angle H the same size as any of the other angles down there? Which one? Angle E. Angle H is congruent to angle E. Why? Vertical angles theorem. All right, so now I know E is the same size as H. Well, if A is the same size as H, and H is the same size as E, what would that mean? Close, not equal. Congruent, yes. Angle A is congruent to angle E. What are we using to be able to say that? Be careful. Transitive property. That is my transitive property. I want you to look at angles A and E. What's the name for my angles that are in matching corners like this? What'd you say? One of them's exterior, A is exterior, but E is in between those two. Those are corresponding. Corresponding is where I have matching corners. So this one is upper left, where those two lines cross. This one is also upper left, where those two lines cross. Those are my corresponding angles. And we just showed that my corresponding angles are congruent. We said A and E are the same size. So if my corresponding angles are congruent, and they are, that means those two lines, V and W, are paralleled by my corresponding angles theorem converse. Remember, we use the converse when I want to show that the lines are parallel. All right, let's flip over to page 6. Actually, hold on. Before we flip over, I want you to look at the original two angles they gave us, A and H. What's the name for this type of an angle pair? Those are alternate exterior angles. So we just proved the alternate exterior angles converse. Once we prove something, we are allowed to use it in a proof later on as a reason. So now when I look at a diagram, if I know my alternate exterior angles are congruent, I can say those lines would have to be paralleled by the alternate exterior angles converse. All right, now we can flip the page. I want to try another one that's very similar to this one. What should my first statement be here? Angle 6 is congruent to angle 3, and my reason for being able to say that? It is given. So I'm going to mark that on my picture. Angle 6 is congruent to angle 3. Look up here by angle 3. Right here where these two lines are crossing, are there any other angles that are the same size as angle 3? Angle 2. Angle 3 is congruent to angle 2. Why? Vertical angle theorem. Well, if 6 is the same as 3, and 3 is the same as 2, then what else would have to be true? Yep, 6 is congruent to 2. What did we just use to be able to say that? Transitive property. I want you to look at angle 6 and angle 2. What do we call that angle pair? Upper right corner? Those are corresponding angles again. And I know I just showed that my corresponding angles were congruent. So if those corresponding angles are congruent, what does that mean about lines J and K? That's my reason for it, but what can I say about line J and line K? They are parallel. Line J is parallel to line K, and the reason I'm allowed to say that is my corresponding angles theorem converse. Again, converse because we showed that the lines were parallel in the end. We started off by knowing about congruent angles, and we ended up making a statement about lines being parallel. What do we call that original angle pair that we were given? Angle 3 and angle 6. Alternate interior angles. We just proved the alternate interior angles converse. So now, when I look at a diagram, if I know from the beginning that alternate interior angles are congruent, then I can use that to say that the lines are parallel. I don't have to walk through this whole proof all over again. Let's go look at number 3. Do I start off by knowing that angles are congruent in number 3? They start off by telling me about parallel lines. Let's write that in as our first statement. Line K is parallel to line W. Line X is parallel to line T. And why am I allowed to say that? That is given. All right, so X and T are parallel. K and W are parallel. Marking that on my picture. All right, so I know these lines are parallel. It tells me angle 11, this one right here, is supplementary to angle 13, this one right up here. What's the transversal that connects 11 and 13? X. Are these on the same side or opposite sides of X? Same side. Interior or exterior to the other two lines? Interior. So what do we call this? Consecutive interior. And what do we know about consecutive interior angles? They are supplementary. Since I knew the lines were parallel at the beginning, by the consecutive interior angles theorem, I can say that 11 is supplementary to 13. Well, then we have angle 13 is congruent to angle 14. What's the transversal that's connecting 13 and 14 together? Transversal is K. These are corresponding angles. And corresponding angles are congruent or supplementary? They are congruent by my corresponding angles theorem. All right, that's nice. So I know that 11 and 13 are supplementary. I know that 13 and 4 are congruent. What am I supposed to be proving in all of this? 11 is supplementary to 4. Well, here I said that 11 was supplementary to 13, and then right after that I said that 13 and 4 were congruent. So can I say that 11 and 4 are supplementary? Yes, angle 11 is supplementary to angle 4. What am I using to be able to say that? This one had 13. This one now has 4. I want to use transitive, but in this case, because I don't have a bunch of things that are congruent, I have supplementary things here. I'm going to use substitution here. There's substitution. All right, let's do one more and call it a week. We get to fill in this whole thing. What do we start off by knowing in number 4? What do we begin with? L is parallel to M, and what else? S is parallel to T. My reasons? Given. All right, I'm going to go ahead and mark that on the picture. L and M are parallel. And then S and T are parallel. We're supposed to prove that 7, this one down here, is supplementary to 12, this one up here. Well, I know that 12 and 13 would have to be the same size because those are what type of angles? Alternate interior angles. So angle 12 is congruent to angle 13 because they are alternate interior angles. But wait, 13 and 8 are also what kind of a pair? 13 and 8 are also alternate interior angles. So angle 13 is also congruent to angle 8 by the alternate interior angles theorem. All right, so help me walk through this. If 12 is the same size as 13 and 13 is the same size as 8, what would that mean? 12 is the same size as 13, 13 is the same size as 8. Angle 12 is congruent to angle 8. What did we just use to be able to say that? Transitive. We're supposed to talk about supplementary. Look at 7 and 8. Are those two supplementary? Why? What kind of a pair do we call 7 and 8? Linear pair. Angle 7 is supplementary to angle 8 by the linear pair theorem. Can I say that 7 is supplementary to 12? Why? Substitution. Angle 7 is supplementary to angle 8 or angle 12 by substitution. Don't forget your homework is due on Monday. Monday and Tuesday we'll review for your test. Have a great weekend, everybody.